Right now, the National Hurricane Center is tracking a tropical wave that has just pushed into the central Caribbean, its axis running south from near the Venezuelan coast, moving west at about 15 knots. A second wave has entered the southwestern Caribbean near eastern Panama, moving on a similar track. Neither one is organized right now. Neither one has significant thunderstorm activity wrapped around it yet. And the Hurricane Center's own outlook issued this morning says, in plain language, that no tropical cyclone formation is expected anywhere in the Atlantic, the Caribbean, or the Gulf over the next 7 days. So let's be honest about that up front, because it matters for how you should actually think about this. This is not a storm. It's not even a storm in waiting yet. But it's exactly the kind of system meteorologists watch every single time it enters the Caribbean, because this basin has a well-earned reputation for turning an unremarkable tropical wave into something dangerous with very little warning, especially once it reaches warmer water further west. So today we're breaking down what a tropical wave actually is, why forecasters track every single one that crosses into the Caribbean, regardless of how disorganized it looks on day one, what would actually need to happen for this particular wave to develop, and why this year's overall pattern makes that outcome less likely than usual, though not impossible. No manufactured urgency here, just the mechanics of how tropical development actually works and what's realistically on the table. If you want tropical weather tracked accurately, without turning every wave into a 5-alarm crisis before there's any data to support it, this is exactly the channel for that. Drop a comment and let me know if you're anywhere in the Caribbean, the Gulf Coast, or Florida, since you're the ones who will want the earliest possible heads up if either of these systems actually starts organizing. And if you want that update the moment the outlook changes, subscribe and turn on notifications. Let's get into the actual mechanics of this. A tropical wave, sometimes called an easterly wave, is essentially a ripple of low pressure embedded in the trade winds, typically originating off the coast of West Africa and drifting westward across the Atlantic. Picture the trade winds as a steady river of air flowing from east to west across the tropics. A tropical wave is a kink in that river, a spot where the air is converging slightly and rising rather than flowing smoothly, which can trigger clusters of showers and thunderstorms along its axis. Dozens of these waves march off the African coast every hurricane season, and the vast majority of them never become anything more than a stripe of disorganized rain showers that eventually dissipates or merges into some other weather feature. What makes a small percentage of these waves special is that, under the right conditions, warm ocean water, low wind shear, sufficient atmospheric moisture, and enough spin already present in the wave structure, that loose cluster of thunderstorms can begin organizing around a common center of rotation. Once that happens and sustained winds reach 39 miles per hour with a closed circulation, it gets upgraded to a tropical depression, then a tropical storm, and eventually, if development continues, a hurricane. The wave currently in the central Caribbean and the one entering near Panama are both right now sitting at the very first stage of that entire process, an unorganized ripple in the wind field with little to no thunderstorm activity currently attached. Getting from where they are today to an actual named storm requires several specific ingredients to line up. And as of this morning's forecast discussion, forecasters aren't seeing that alignment happening within the next week. Given that description, you might reasonably ask why this is even worth a video. Here's why. The Caribbean and the Gulf of Mexico that so many of these waves eventually track toward are some of the most efficient hurricane incubators on the planet, precisely because of how warm the water tends to run through the peak of summer. A wave that looks completely unremarkable crossing the central Caribbean can, if it survives its trip west without getting torn apart by dry air or wind shear, reach the exceptionally warm waters of the western Caribbean or the Gulf and begin organizing rapidly, sometimes within 24 to 48 hours of showing its first real signs of a defined center. That's exactly the sequence that has preceded several of the most damaging Gulf Coast hurricanes in modern history. A forgettable tropical wave, a week out that nobody was worried about, followed by a rapid, late-stage scramble to organize once the wave reached the right water. This is why the National Hurricane Center issues its tropical weather outlook multiple times a day throughout hurricane season, tracking every single wave crossing the Atlantic and Caribbean, assigning each one a formation probability over the next 2 and 7 days, even when that probability sits at 0%, as it currently does for both of today's waves. It's not that forecasters expect every wave to become something, it's that the cost of missing the one wave in 20 or 1 in 50 that actually does organize quickly is high enough that continuous monitoring of all of them is simply standard practice, not an overreaction. For either of today's Caribbean waves to actually develop into something, several things need to happen in sequence. First, the wave needs to survive intact as it continues moving west, since dry air intrusions, upper-level wind shear, or interaction with land, in this case Central America, Venezuela, or the northern coast of South America, can easily disrupt or destroy a weak, disorganized system before it ever gets the chance to consolidate. Second, it needs to reach a stretch of ocean warm enough and with a deep enough layer of warm water to sustain intensification, generally accepted as around 80 degrees Fahrenheit or warmer, extending down to a reasonable depth, rather than just a thin surface layer that a developing storm's own churning action would quickly disrupt. Third, the surrounding atmosphere needs low to moderate wind shear, meaning winds at different altitudes blowing in similar directions and speeds, so a developing storm's vertical structure doesn't get torn apart before it can consolidate. And fourth, it typically helps to have an existing area of lower pressure or pre-existing disturbance for the wave to interact with, giving it a head start on developing the kind of organized, closed circulation that defines an actual tropical cyclone. Right now, neither Caribbean wave has significant convection wrapped around it, which is usually one of the earliest visual signs forecasters look for when a wave might be starting to organize. Persistent, deep thunderstorm clusters need to develop and, more importantly, need to stay roughly in the same place relative to the wave's low-level circulation, rather than repeatedly forming and collapsing in different spots, which is often the first sign that a wave is beginning to consolidate into something more organized. Here's the bigger context that makes this year's outlook different from what forecasters might say about an identical-looking wave in a more active season. The 2026 Atlantic hurricane season is unfolding under the influence of a strengthening El Niño pattern, and El Niño has a very well-documented, very consistent effect on Atlantic hurricane activity. It tends to suppress it. El Niño increases upper-level wind shear across the tropical Atlantic and Caribbean, and that added shear works directly against the third ingredient described above, tearing apart the upper structure of developing systems before they can fully organize. Seasonal forecasters at Colorado State University, who've been tracking Atlantic hurricane activity for decades, have specifically pointed to a strong El Niño as the reason they've reduced their overall storm activity forecast for this year, projecting total Atlantic hurricane energy running somewhere around 40 to 45% of the long-term historical average. That's a substantially quieter season than normal, driven directly by exactly the kind of wind shear that today's Caribbean waves would need to overcome in order to develop. At the same time, it's worth being precise here, rather than overstating the case in the other direction. Sea surface temperatures across the broader tropical Atlantic and Caribbean, the stretch forecasters sometimes call Hurricane Alley, running from the African coast westward toward Central America, remain warmer than average this year. So the fuel is genuinely there. What's currently missing, at least for these two specific waves, is the combination of favorable upper-level winds and enough existing organization to actually tap into that fuel efficiently. A below-average season driven by El Niño-enhanced shear doesn't mean a zero-risk season. It means the odds of any individual wave successfully developing are lower than they'd be in a neutral or La Niña year. Not that development is impossible. This is really the core of tracking tropical waves responsibly, and it's worth explaining the process because it's genuinely different from how a lot of severe weather coverage works. With a severe thunderstorm outbreak or an approaching hurricane that's already a named storm, forecasters can give you a fairly specific window, a day, sometimes even down to a several-hour range, for when conditions will actually turn dangerous. With an unorganized tropical wave sitting at 0% development probability, that specificity simply doesn't exist yet, and pretending otherwise would be dishonest forecasting. What you actually get instead is a rolling series of updates. The National Hurricane Center's tropical weather outlook gets reissued 4 times a day during hurricane season, each time reassessing every active wave and disturbance in the Atlantic Basin, and assigning updated 2-day and 7-day formation probabilities based on the latest satellite imagery, model guidance, and observed convection. If either of today's Caribbean waves begins showing signs of organizing, meaning consistent, sustained thunderstorm activity developing around a more defined area of low pressure, that formation probability will start climbing in these updates well before anything gets a name. That's your actual early warning system for a story like this one. Not a single dramatic alert, but a gradual, transparent escalation in probability across multiple daily outlook updates, giving you and everyone else in the storm's potential path several days of lead time if a wave genuinely does start to organize. Even in a quieter El Niño-suppressed season like this one, it's worth understanding why any system moving through the Caribbean gets more attention than an equivalent wave still crossing the open Atlantic thousands of miles from land. Geography is the simple answer. The Caribbean is ringed by island nations and connects directly to the Gulf of Mexico and the U.S. Gulf Coast, meaning a system that does organize here, has a comparatively short distance to travel before it's threatening land somewhere, compared to a wave still out in the middle of the Atlantic that has open ocean to cross, and more opportunities to encounter dry air, shear, or unfavorable conditions before ever reaching a coastline. The Gulf of Mexico specifically has a reputation among meteorologists for occasionally fueling exactly the kind of rapid, late-stage intensification described earlier, since its waters can run exceptionally warm through the peak of summer, sometimes warm enough to fuel a system's jump from a weak tropical storm to a major hurricane in the final day or two before landfall, leaving coastal residents with less warning than a slower developing system out in the open Atlantic would provide. That's precisely why forecasters don't relax their attention on a wave just because it currently looks unremarkable while crossing the central or eastern Caribbean. The real test often comes later, once, or if, it reaches the western Caribbean or Gulf. If you live anywhere in the Caribbean, the Gulf Coast, or Florida, here's the honest, practical takeaway from today's outlook. There is currently no tropical cyclone threat requiring any specific action. No watches, no warnings, no elevated formation probability on either wave currently being tracked. This is squarely in the category of routine seasonal monitoring, not an emerging emergency. That said, since we're still in the heart of Atlantic hurricane season, this is a perfectly good moment to do the kind of preparedness work that's much easier to handle calmly now than in a rush later. Know your evacuation zone if you live in a coastal area. Make sure your household has several days of water, non-perishable food, and any needed medications on hand as a baseline, independent of any specific storm threat. Check that your phone's severe weather and emergency alerts are actually enabled, since those systems are exactly how you'd receive updated information quickly if either of today's waves or the next one behind them does eventually organize. None of this is because today's waves are dangerous. It's because hurricane season preparedness done calmly in a quiet week is always more effective than preparedness attempted in a panic once a storm already has a name and a 5-day forecast cone pointed at your coastline. Zooming out, this year's Atlantic season fits into a pattern that's been forming since the seasonal outlooks were first published back in the spring. A strong El Niño, expected to persist through the peak of the season, has consistently pointed toward a below-normal year for Atlantic hurricane activity, with forecasters projecting overall storm energy well under half of the long-term historical average. That's genuinely good news for anyone along the Gulf Coast or Atlantic seaboard, bracing for another potentially brutal season. But it comes with an important caveat that every credible seasonal forecaster repeats every single year, and it's worth repeating here too. A below-average season on paper does not guarantee a low-impact season on the ground. It only takes one system finding the right combination of warm water, low shear, and favorable timing to produce a landfalling hurricane, even in a year where every other wave that crossed the basin fizzled out exactly like today's two are currently forecast to do. Seasonal averages describe the basin as a whole. They don't protect any individual coastline from the one storm that beats the odds. Over the coming days, expect the National Hurricane Center to continue reissuing its tropical weather outlook on its normal 4 times daily schedule, tracking both of today's Caribbean waves as they continue their westward journey. The specific things worth watching in each update are whether either wave's formation probability moves off 0%, whether new, more persistent thunderstorm activity starts wrapping around either system's axis, and how each wave interacts with the terrain of Central America, Venezuela, and the northern coast of South America as it continues moving west, since disruption from land interaction is often exactly what keeps a wave like this from ever organizing at all. We'll be watching every one of these updates, and we'll have a follow-up the moment anything changes, whether that's an upgrade to a tropical depression somewhere down the line, or simply confirmation that both of today's waves dissipated quietly the way the vast majority of Caribbean tropical waves do. If you want that update delivered the moment it happens, rather than finding out secondhand, subscribing and turning on notifications is the most reliable way to stay ahead of it. Before you go, drop a comment and tell me where you're watching from, especially if you're anywhere in the Caribbean or along the Gulf Coast right now. And if you have ever watched a tropical wave that everyone assumed was nothing suddenly turned into a serious storm within a day or two, share that story below, because that exact scenario is precisely why we track even the most unremarkable looking waves this closely. If this breakdown helped you understand how tropical development actually works instead of just reacting to another alarming headline, A-like helps this reach people along the coast who genuinely benefit from accurate, level-headed tracking instead of manufactured panic. Stay weather aware, keep an eye on the Outlook updates, and I'll see you in the next one.